people for binomial theorem. Now, here you have an expansion a plus x the whole raised to n. Let me just check this. Yeah. So here is an expansion a plus x the whole raised to n. So if I just make you understand this, this is a very simple expansion wherein if you see this a plus x the whole raised to n, this expansion works this way. For the people who don't remember this, a very easy way to remember this is we start with NC0. Now, what is NC0? It is NCR combination where N stands for total, R stands for to be selected. Now, I won't get into detail with NCR and all that. That all is expected that you people know it. In short, NCR. NCR ka formula is N factorial upon N minus R factorial into R factorial. Now, this is what you have. Now, when you expand this, what happens, right? How do you write this? You start with NC0. So simple, NC0, then you write NC1, NC2. You go on till NCn. Simple, you add all of them. Now, the first term is A. This is your first term, right? So the first term goes on decreasing. Decreasing means it will start with the highest power, that is n. So A raised to n minus 1 goes on decreasing. You see this? And last, this becomes A raised to 0. In a similar way, the second number, this is your second number. The second number goes on increasing, right? So increasing, it has to start from 0. So here you have x raised to 0, x raised to 1. This is x raised to 1. Next is x square. It goes on till x raised to r and x raised to n. So this is the simplest way to have this thing. Now, any r plus 1th term in middle is of this format. And hence, we take this thing as a generalized term. This is your generalized term. See this. It is summation r equal to 0 to n, NCR, a raised to n minus r, x raised to r. So when you put R0, you get the first term. When you put R1, you get the next term. You get the next term and it goes on, right? So when R is 0, you get the first term. I hope you understand this. Your first term is when R is 0. So you have NC0. See this. This is your first term, right? NC0 into a raised to n minus 0 into x raised to 0, right? In a similar way, the rth term, or I would say r plus 1th term. See, this is 1, first term. So this is 0, 1 less. So you'll have NCR into a raised to n minus r into x raised to r. So this is a generalized term from this expansion. So I hope you understood this particular part, right? So this is the way you get all these things. Simple enough. Now, in this, you can have simple expansions, right? What is 1 plus x raised to n, expansion, etc., etc. You can have an expansion of a simple question, might be, all simple questions have already been done. But still, if you want, say, for example, I have 2 minus x raised to n, I can take n as 7. And if I want an expansion to this, how do I start? The same way as I said earlier. You start with 7c0, next is 7c1, next is 7c2, and this goes on till the last term, 7c7, right? Now, the first term is 2, right? So 2 raised to highest power, 2 raised to 7. This is 2 raised to 6. This is 2 raised to, right? It goes on decreasing, right? So 2 raised to 5. And the last has to be 2 raised to 0. A similar way, you have minus x. See this. This is minus x, right? So here you have minus x raised to 0. So it's same. Here you'll have minus x raised to 1. You understand this? So if I don't have that much space, I write it as x, and this becomes minus. I hope this is understood. This becomes minus. Right? Here you'll have minus x square, so that's positive, so x square. And the last term would be minus x raised to what? 7. So a negative number finally. I hope this is understood. Clear? A simple expansion of this. Right? Okay, so this is what you have in the expansion. This is your nth r plus 1th term, right? Now, if they have asked you find a term independent of x in the expansion of this, independent of x would mean what? Independent of x would mean any term, any coefficient with x raised to 0, right? So what would I do is, I don't know. So let that term be any r plus 1th term. So you have an expansion. See this. Your n ka value is 6. This is your a and this is your b. You understand this? You just substitute here, right? You simplify with the value of x. So here, x raised to, see this, x is to 2, 6 are 12, 12 minus 2 are Agreed? And from here, I'll get x raised to r in the denominator. It goes above and becomes minus r. Here you have it. See? Now I know that this is a general term, that is r plus 1th term. And this r plus 1th term has x raised to this much. But I want my term as k into x raised to 0. So I'll equate this part with 0. See this. And I get r ka value is 4. And r ka value is 4. Which term it is? It is 5th term. By r plus 1. Na? So 5th term. R ka value 4. So it is 5th term which has x raised to 0, or which is independent of x in this expansion. I hope that's understood. Clear? So in this way, I just clear off all this. Clear. Yeah. Yep. So in this way, we can have all these expansions. This is easy stuff. I don't think so there's something that is difficult. This is the basic thing, right? Okay, this is a good question. Yeah. Find the expansion of x cube y square in the expansion of this. Now you have two terms, right? I'm sure you could have a question in this, right? So find the coefficient. Find the coefficient here. So again, you have, yeah. So find the coefficient x cube y square ka in this expansion. Now try understanding this. Getting x cube y square in this expansion, I'll take x from here. Then what do I require from here? If I take x from here, x means I take 2x from here. 2x is multiplied with, 2x is multiplied with a term from here to get x cube by cube. What is that term? That term has to be some constant into what? Into, if I want x cube, it has to be x square into y square. Do you understand this? Right? I just use a different color pen. Yeah. Y square, do you get it? Why so? Because when 2x is multiplied with this will give me x cube and y square. Done? Okay. So one thing that I require from this expansion is this. Agreed? Also, when y is multiplied with something, what should y be multiplied with? Y should be multiplied with some constant, let that constant be say p. Some constant into x cube y. Right? Now doing this, you will get x cube y square. Do you understand that? Doing this, you will get something into x cube y square. You understood? You require the something. I hope you understood the sum. So now my aim is in this expansion from this bracket, that is the second bracket. Right? I am supposed to find x square y square ka coefficient and x cube y ka coefficient. Do you understand this? Right? So that I can get p and k from here. Right? Because if you understand this, x cube y square will have what? See, understand this. Here, x cube y square, if I take common, x cube y square, if I take common, what remains? 2k remains, 2k plus p. So I'm interested in finding this k and p, right? How do I get p and p? K is coefficient of this and p is coefficient of this. Did you understand this? So now, how do I proceed? This is to be done in 2 steps. First step, to find the k. First step is to find the k, right? How do I find k? The same process has to be done for the next part also. How do I find k? I will get k because it is a coefficient of x square y square. So I'll just have an expansion of this. What is r plus 1th term of this expansion? R plus 1th term of this expansion is, I will have 5 because this bracket has raised to 5. I'm talking about this bracket, guys. X plus y by x, the whole raised to 5. Right? Okay. So it is 5 cr into first term x raised to 5 minus r into y by x raised to what? R. So on simplifying this will give me 5cr as it is into x raised to 5 minus r into y raised to r. I hope that's understood. Clear with the idea? Done. Now from here, you get good amount of hint directly that R has to be 2. R has to be 2. You don't have to waste your time because you want x square y square, right? To get k, k ka is x square y square, right? And here, this is your k ka value, right? And R has to be 2, right? So from this, I get R ka value is 2, right? So third term, R plus 1, na? So 2 plus 1, third term. Third term, then a expansion will have x square y square. And from there, I'll get k ka value. Right? So from here, can I say my k ka value directly from here? Can I say my k ka value is 5c2? Because this was k, right? This was k, right? 5c2. So that is my k ka value. Here, k ka value. Now similarly, I want p. I'm sure you will be able to find p. What is coefficient of, what is a variable in p? X cube by into p, right? So that's my second step, right? Again, my r plus 1th term. Again, my r plus 1th term. It has to be what? It has to be what? The expansion doesn't change. The expansion is the same way, right? The expansion of the bracket doesn't change, right? So it has to be same. 5cr into x raised to 5 minus 2r. I'm taking it from top into y raised to r, right? Right. And I want this. Now here y ka value is 1. So r has to be 1, right? R has to be 1, right? That means, forget this. Now I'm talking about P. So what is P in this case? This is P. This part is P. So P is what? P is 5C1, right? So that's 5. 5C2, that's 5 4s are 20. 20 by 2, that's 10. So you have 10. You input it here. You input it in this step, right? You input it in this step, right? So if you input it in this step, what do you get? You input in 1 here, right? Okay, there's too many 1s, 2s. Okay, Roman, right? So you substitute in Roman 1s. What do you get? You get the coefficient as 2 into k, that's 10, plus p, p is 5. So 20 plus 5, that's 25. I hope that's understood. Clear? Go through this. I repeat step by step again. Just understand this. Here, this is the expansion that you have. First bracket has power 1, so don't worry much about it. It means the first term 2x should be multiplied by something from this bracket. Now that something has to be this to give me x cube y square. Do you understand this? Right? So I wrote it as k into x square y square, so that when this gets multiplied with 2x, will give me 2k. You understand this? X cube y square required plus y should be multiplied by something from this bracket. Now what it should be from this bracket? It has to be this. I hope you understand. Now from this step, from this particular step, you understand this? From this particular step, I come down to this step, right? So there's too much of writing. I'll just take one more color to make our life better. Better color is green. Yeah. From here, I got this step. From here, I got this step. This was our thinking pattern. Have patience, guys. It's a tough sum. You won't get it easily, right? I simplified this stuff and I got this. This was my Roman 1, right? Next, I did this all things. Okay? So now, here, on simplifying this stuff, just understand. If I take x cube y square common, what would I get? I get 2k from here, and p from here. I hope that's understood. So my aim now is to find k and p. Simple. How do I find k? Here is a step. Find any r plus 1th term. Equate it with what you want. This is my r plus 1th term. I equated with this thing, right? So when I equated with this thing, see, y ka power here is 2, right? I want y ka power 2, so r has to be 2. Simple. Similarly, from next, y ka power is 1. Why do you want 1? Refer to this. Here. You understanding this, right? So y ka power is 1. So r ka value has to be 1. Do you understand this? R ka value has to be 1. Done. So accordingly, I got one number P, I got K, I inputted in Roman 1, I got the coefficient. I hope you understood. Clear? If not, we'll have some more ways to do it. Okay. So that was everything that was related to this question. Okay. We move ahead with our work when I say so. Let's see. Next, a generalization pattern. I suppose that is enough for this video. In fact, I can go further. Yeah, let's go further. Let's make you understand something more, something much more interesting. Here, here I have a geometric series. See this. You have a geometric series. Here. Here, this is a geometric series. Now, what is the geometric series? First term, 1. Next term, x square, x cube. Why a geometric series? I'll make you understand. Don't worry. Have patience. Right? So, this is a geometric series. Right? With this geometric series, what is my first term? My first term is 1. Right? What is the common ratio? The common ratio is x. So, if I want to find sum of infinite term, what is the formula? The formula is a upon 1 minus r. Here. So, this is sum till infinity. The only condition that you should have is this. When finding sum to infinity, right? If you have this condition, the series converges. The series converges. That means it converges to a finite value. You understand this? So this is what you have. Now, see the magic now. Can I say 1 upon 1 minus x? That is the same thing. The same thing. Here. Can I say it is 1 minus x raised to minus 1? So automatically, this infinite series ka sum is this much, right? Now think vice versa. If I ask you to find 1 minus x raised to minus 1, you can write it this way. Did you get it? What I mean to say? So here comes binomial. 1 minus x raised to minus 1 can be written this way directly. Did you understand this? Clear with the idea? So people who want to just ratify the formula, this is the way you can ratify the formula. I'll give you one very good basics related to this, right? But before that, you have something more in the this thing, right? So let's understand this, something more. I cannot, can I scroll? Yeah, I think I can scroll. Just see this. Now leave that letters. See the other part. I think I have to clear it. Yeah. Yeah. So now the next part. See the next part. See the way they have found 1 minus x raised to minus 2. It's interesting. So 1 minus x raised to minus 2 can be written as 1 minus x raised to minus 1, the whole square. So that means twice this thing. So they have written it this way, 1 minus x raised to minus 1, which is very simple. You already know. 1 plus x plus x square plus x cube plus x 4 goes on and on. Same way, same way. Now you multiply 1 with everything in the bracket. I get this term. I multiply x with everything from this bracket. I get this. Similarly. And accordingly, I got my answer. See this? 1, x plus x 2x, x square plus x square plus x square 3x square, x cube plus x cube plus x cube 4x cube, plus goes on. Right? Now this right now must be, you must be getting it, oh God, it's such a great thing. No, I somehow think this is the most stupid thing to be done. Reason. This way, to find 1 minus x raised to minus, 1 minus x raised to minus 2, this thing, I require 1 minus x raised to minus 1. Not only this, see this further. 1 minus x raised to minus 3, I require 1 minus x raised to minus 2. And again, who will go on doing all this multiplication? So there has to be a smarter method, right? Now, either you remember this as a formula, people who want to ratify again, doesn't want to understand the basics, these are the formulas, you ratify this formula. I'm giving you a basic, people who want to understand the basics, stay in. See, understand the basics now. Here, we all know as to what, how do you expand the things, right? So expansion I have shown at start. As I said, this lecture was more of people, for pro people, I would say, or for people who already know the stuff well. I mean, know the basics well, right? Okay, now just check in here. So I have 1 plus x raised to n, right? Yeah. Now expansion, as I have taught you, right? You start with NC0, right? And 1 raised to anything is 1 only, so I don't write it. And x is to 0, so I don't write. I hope you understand that. Next is NC1, x plus NC2, x square plus nc3 x cube plus goes on till you'll have ncr x raised to r goes on till last term ncn x raised to n. Simple, right? Now this nc0 and all this works. Remember this, in ncr the condition for r has to be less than equal to n and r has to be greater than equal to 0. Try understanding this, right? I hope you understood this. But when I'm talking about all this value 1, 2, 3, whatever, right? And here this number n, this we talking about, it has to be greater than 0. Here n is negative. Do you understand this? N is negative. So in such cases, what do we do is we simplify this first, right? So what is NC0 ka simplification? NC0 ka simplification is n. You can work it out, right? Plus, what is NC1 ka simplification? Simplify it, no? N into n minus, okay, my bad. Yeah, simple mistake, yeah. What is NC0? NC0 is 1. NC0 is 1 here. What is NC1? NC1 is n. You can work out. What is NC2? N into n minus 1 upon 2 factorial. Work it out. What is NC3? N into n minus 1 into n minus 2 upon 3 factorial into x cube. This goes on till last term NCN. NCN is again 1 into x raised to 1. Right? Now, this was your funda. 1 plus x raised to n ka expansion. You are done, guys. Now, this is the expansion of 1 plus x raised to n. Now, put n as negative minus n. Now, put instead of n minus n, and instead of this x, you put minus x. So, what do? Instead of x, I put minus x, and instead of n, now I put minus n. Just check out what do you get. So, I get 1 minus x raised to minus n. I have 1. Both are negative, so it will still remain positive. Next, this is minus n. And minus n minus 1 can be written as minus n plus 1 whole bracket. Do you understand this? Upon 2 factorial. Into minus x square is x square only. So now this minus and this minus. Do you understand this? Do you see this both minus? So this minus and this minus gets cancelled and becomes plus. I hope that is understood, guys. Clear? So now see your answer. Guys. See your answer. N into n plus 1 upon 2 factorial. So n into n plus 1 upon 2 factorial. Do you understand this? Into x square. Similarly, when you go ahead, just check it out. N negative, a negative from here, and a negative from here. 3 negatives. So yet you have negative. X cube will give you one more negative. 4 negatives. So a positive thing. So n into n plus 1 into n plus 2 into x cube upon 3 factorial. Check out the next term. Here. I hope you understand this, right? So this is the way it goes on. So this is the basics, right? So your thing is this. You should be knowing this, right? And again, this is no magic, nothing that you need to remember. It's a simple expansion, a very basic expansion. I hope that's understood. Clear? Now, what would this do? Whether n be negative, try understanding this. What are we doing? Whether n be negative, as it is in this case, whether n be fractions, right? You'll be able to use this formula. Which formula? This formula, 1. I hope you understand. So if n is negative or n is some fraction, you'll be able to use this formula directly. And again, I say, don't remember the formula. It comes from this. So this is nothing new that you're doing it. I hope that's understood. Where it could be used, I'll give you an idea right away. I'm not making this video more longer. I'll just give you an idea as to where this can be used. Understand this. Here. This can be used in sums of this kind. See this. The root of 1 plus 2x. So that's fraction raised to half. You just input it. You remember the formula? 1 plus nx. X in this case is 2x. Right? Plus. You go on. Go for 2 or 3 terms and you have the answer. I hope that's understood. See, this is the formula that we did right now. 1 plus x raised to n ka formula. The same formula have been applied here. I hope you understand. So go back to the video, understand the formula, and apply it. Keep that formula in front of you and apply it. And be satisfied that you know how to apply the formula, right? And apart from that, you also know how to understand the formula. You know how to make that formula, right? Okay. Now you have all such kind of sums. 2 upon 1 minus 3x. So 1 minus 3x is to minus 1. Now you can do and you can expand it. See this? Right? All negative powers. So this is negative powers, right? Here, 1 plus x, 1 minus x, the root. Later you can expand this. Huh? Simple. 1 plus x raised to fractional power. 1 minus x raised to negative fractional power. Simple. Use the same expansion. Here, same expansion. I hope that's done. So this was the more complicated kind of sums. So right now that would be all for the video. Later I'll be posting this video. So thanks guys for watching.